Aloha, and welcome to ThinkTech. The name of this show is For the Benefit of Humankind. I'm Mike Deweert, Chief Scientist for ThinkTech Hawaii. And when I was a kid in school, I was taught that the purpose of science is to predict and control nature for the benefit of humankind. So that's hence the name of the show. Today I don't have a guest. Well, I do have a guest. I have Jay Fidell here.
I'm your foil man. I'm going to keep you on the right track.
Keep me on the right track. And today we're going to talk about asteroids, because there's been a couple of interesting with pass-bys in 2 days in a row now of big asteroids near the Earth. But I think first we wanted to talk about climate change.
Yeah, let's do a report on climate change. And before we do that, let me tell everybody that we have a Twitter box here, a little Twitter tablet thing. And if they want to send it, a message or a comment or a question or whatever, they can send it to us at Twitter handle ThinkTech High. ThinkTech High, H-I, okay?
Yeah.
Let's see what happens.
Yeah. So what asteroids and climate change have in common is they both could extinct our species. The asteroids we can't control too much. Climate change, we got the levers in our hands, and we're going full throttle ahead right now.
Are you saying that we could really solve the problem in climate change? Do we have? I mean, if everybody got in the boat together, could we solve it? Yeah.
Absolutely. There's no reason we have to be spewing carbon into the air the way we're spewing it. Nuclear power, especially fast neutron nuclear reactors that burn up more than 99% of the fuel you put in, would reduce the nuclear waste problem and produce 100 times as much energy as what we're using now. So there's no question that if we really had a crash program as a planet to get off fossil fuels between the sunlight, geothermal, hydropower, nuclear, we could do it. It would be expensive, but we could do it, and we would have energy for the foreseeable future for thousands of years.
Does it reach a point where we couldn't anymore? In other words, if you say that we're not going to do it, and there's a point out there where humanity ends, it's just over. Is there a point of no return in the middle?
Yeah, James Hansen, a former NASA scientist who has been trying to raise the alarm for decades on climate change, he says that once we start burning all the tar sands in Canada and exploiting oil shale, if we go that far, it's game over. We have hit the tipping point, we're going to go past it, and we're in danger of making the planet uninhabitable forever, not just for the 6,000 years it takes normally for the carbon to come out of the air, but we might push ourselves into a point where we evaporate enough water that now the water is the greenhouse gas. And once the water is in the atmosphere in high concentrations, the sunlight starts to break it apart, the hydrogen escapes to space, now we have no more water. And then it's the point of no return, heading towards a Venus-like condition.
What is a Venus-like condition?
Venus is an atmosphere. Venus is almost exactly the same size as Earth, almost exactly the same gravitational pull as Earth, but its atmosphere has got a lot of carbon dioxide in it, so much that it acts as a huge greenhouse blanket, and the surface of Venus is about 900 Fahrenheit. Lead melts on the surface of Venus.
Whoa. And life can't exist in that environment.
No, it can't exist in that environment. Now, Venus is much closer to the sun than we are, but Earth is only 5% away from the uninhabitable zone. I mean, if we were 5% closer to the sun than we are, we'd already be uninhabitable in terms of heat. And so here we are, just a little bit within the inhabitable zone of our star, and we are doing everything we can to make sure that we become an uninhabitable planet, it seems.
How does the end stage work then? From where we are now to where it gets uninhabitable?
Yeah, we don't know how long it will take.
Okay.
Right. But what's going to happen, from the archaeological record, we know that if the atmospheric carbon concentrate gets to 450 parts per million or so and stays there, and we're 400 now, if it gets to 450, the Antarctic ice cap will melt. If the Antarctic ice cap melts, sea level rises 250 feet or so, which is bad. But the worst thing is that what happens is as the sea level is rising, the primary productivity along the coast, the biodiversity, the plankton, all that stuff that makes food for fish and stuff has a much harder time. As the sea level is rising, that biological activity goes down because the critters can't adapt fast enough. So now we have the phytoplankton in the ocean are taking less carbon out of the air than they have been. When the Arctic ice cap melts, sunlight will penetrate the water and be absorbed more, so the Arctic Ocean will melt, There's a lot of methane buried in the sediments of the Arctic Ocean. Methane, much more potent greenhouse gas than carbon dioxide. If that stuff comes out of solution, now we have an acceleration. Now, methane doesn't last as long, but it could be that kick that, for over a few hundred years is enough to drive the planet to where we start to evaporate too much water, where we can't get it back, can't get it recondensed into rain. Then we're in a world of hurt. Because once the atmosphere is full of steam and water vapor, sunlight will eventually break the oxygen apart from the hydrogen. The hydrogen escapes to space. Now there's no way to get the water. It's gone. That is a dire scenario. It's one James Hansen thinks is possible if we actually go so far as to burn all the fossil fuels, including the unconventional ones, the oil shales, the tar sands. I think hopefully, now how long that will take is that's the problem, because the ocean can absorb a lot of heat. I mean, the bottom of the ocean is like 40 degrees Fahrenheit, and the surface is 70, around here, Hawaii, 80. You can absorb a lot of heat in the ocean to kind of slow the process down. But once it gets really going, you're done. You can't bring it back. So do we have 50 years? Do we have 200 years? Do we have 500 years to solve this problem? I think it's more closer to the 50 years. I don't want to gamble on the planet. And James Hansen certainly, if you read his book, Storms of My Grandchildren, you get mad at everybody who's trying to impede this from whatever political persuasion. Everybody is saying, we got to stop nuclear energy. Well, we're not going to go back to living in caves. We're not going to go back to having no electricity. But the only other source for enough energy right now for people in cloudy climates, northern hemisphere, northern latitudes where there's not sun all year round, is either fossil fuels or nuclear energy. Here in Hawaii, we're blessed with lots of solar energy. We can probably get a third to half or maybe more of our energy from solar. We could go full force like they do in Iceland on geothermal and try to at least power Big Island and Maui with geothermal. Those things are possible. The planet as a whole, they're going to have to do something like nuclear energy, or we're risking the planet, and the risks are dire. I mean, you and I will probably not live to see an uninhabitable planet.
No, but if you say that at a certain point it's over, then once that conclusion is clear to everybody, will become clear. Even if the media doesn't want to tell us, even if there's all this public relations about how everything's dandy, at some point it's going to become clear that it's over. Then the economy begins to fail because you need optimism for an economy. And at some point, the physical environment we won't be able to live here. And we'll die because we don't have an environment to live in.
And we may try something like geoengineering. I mean, there's we may try to do. I mean, once we put so much carbon in the air, getting it back is hard. It's really hard. It takes a lot of energy to get the carbon back once you put it in the air. There are technologies that let you do it, but it's difficult. You could try also fertilizing the ocean, get the plankton to bloom more, take carbon out. That's unproven. One of the few things that's actually plausible, besides putting the carbon in the air, is spewing something in the air that will reflect the sunlight back to space, either in the stratosphere or in orbit around the planet. Problem is, if you put mirrors or something like that in orbit, you don't get them back. You can't get them out of orbit if you found you've made a miscalculation. You could try emulating a volcano. We've known from observation that large volcanoes can spew lots of dust and sulfur dioxide into the air, and that can cool the planet.
It acts as a mirror.
It reflects the light back, and if it's in the stratosphere, it reflects it back into space before it even gets into our atmosphere and into the ground. Because what happens is once the visible light hits the ground absorbs the light, warms up, re-emits it as infrared, and then that's what's held in by the carbon dioxide. If you can keep the visible light off the surface of the Earth, then you're doing yourself more good than harm. So we know that we could possibly spew sulfur particles into the stratosphere, either via large jet tanker aircraft, something like that. It's hard.
Life as we know it will be over.
It'll be hard.
It'll be hard. And we won't have the same population because the Earth will not sustain that population.
Well, the interesting thing is, we're forcing a climate. James Hansen calculates between 1 and 3 watts per square meter. 3 watts per square meter is about 1% of the sunlight coming down on the planet. So if we could reflect 1% of the sunlight worldwide back to space, we might be able to balance out the climate forcing we're putting on and stabilize the situation.
So fragile, so delicate.
Yeah.
So a big question about global climate change and Hawaii
right.
is the thing you were telling me about before the show about El Nino.
Oh, yeah.
And how, you know, if it keeps going, and it probably will keep going, we're going to get more El Nino. And what does that mean for us? Yeah,
so the Earth has this oscillation, this El Nino southern oscillation, where every once in a while the Pacific Ocean warms up, and they call it El Nino. And that means fewer hurricanes in Florida, but more hurricanes in the Pacific, and stronger hurricanes. And even last year, which wasn't an El Nino year, we had the strongest hurricane ever to hit land, smash the Philippines.
Yeah.
We've been very lucky in Hawaii, since the 1980s. Iniki was the last big hurricane to hit us. And it's not a matter of if, but when there'll be more hurricanes hitting Hawaii.
You were lucky because it only hit Kauai. It didn't hit our population center.
Right, it didn't. Yeah, right. And so if you warm the Pacific Ocean over and above what's in an El Nino, and it won't take too many degrees Fahrenheit of warming. So right now what the hurricanes do is they form off Mexico, come across the ocean, and make a hook north. And they hit that colder water and usually fizzle out before they hit us. They might get past the main Hawaiian Islands while they're doing their hook to get far enough north to hit Kauai. That's what happened with Iniki. What happens is if Hawaii is a few degrees warmer, they don't fizzle out after they do that turn north. And then we get hit. And of course Honolulu's, kind of a big target. Hilo's never taken a direct hit, but that could happen. And it doesn't take much of a warming to greatly increase the force of the wind, the strength of the hurricane. And these hurricanes, you talk about atomic bombs, they're like hundreds, thousands of atomic bombs worth of energy.
They're worse now than they used to be?
Well, it seems that they're getting worse. Now that we were talking about a low statistical number, having the record highest hurricane ever hit the Philippines last year, well, that's one hurricane. You need dozens to say that they're getting stronger. But it looks like that's the trend. That's a trend.
I wake up I see a nice day and I say, oh, what a nice day it is. One day closer to a hurricane.
At least fortunately here in Hawaii, we are going to have warning because they start in Mexico and come across the Pacific, and we'll have days or weeks of warning to try to mitigate the death, move people to higher ground. It's the aftermath that you got to worry about. If it really takes out the port and the airport, if you got really unlucky, now you got to feed the population. We fortunately have military bases here with airlift capability. We probably could keep the population from starving, but economically it would be a long-term disaster, just like what happened with
forever, really.
Because
once people go, they don't come back so quick. I suggest that you take a break.
Yes.
And that we can come back right after that and start talking about our title show, namely about Asteroids, which is another kind of disaster.
Yeah, that would be another kind of disaster. So, this is ThinkTech. The name of the show is For the Benefit of Humankind, and I'm Mike Deweert talking to Jay Fidell, and we'll be back shortly.
Castle and Cook, Hawaii. Investing in Hawaii, creating communities, and providing for the needs of our state. Collateral Analytics, empowering the real estate industry to make better informed property investment decisions. The Foreign Trade Zone, bringing the benefits of the Foreign Trade Zone programs to Hawaii businesses and entrepreneurs. Galen Ho, a senior executive of BAE Systems, a global defense, security, and aerospace company. Hawaiian Electric Company and its affiliates Maui Electric and Hawaii Electric Light Company on Hawaii Island. The Hawaii Energy Policy Forum, incorporating diverse perspectives to design a flexible and forward-looking energy strategy. Hawaii Energy, the state's energy and efficiency program created to help Hawaii's residents and businesses adopt a clean energy lifestyle. Hawaii Gas, helping Hawaii achieve its transition to clean energy and a better energy future. Hawaii Pacific Health, bringing technology and teamwork together to transform healthcare in Hawaii. The High Tech Development Corporation, attached to DBED, is the state's leading technology agency. The Scheidler Family Foundation, supporting educational, cultural, and charitable organizations, including ThinkTech.
Aloha, I'm Mike Deweert. This is ThinkTech for the benefit of humankind, and I'm here with Jay Fidell, and we just finished talking about climate change, which was dismal, but another thing that could extinct our species is a big asteroid impact, and that's in the news lately. Because yesterday, today, there's an asteroid passing by Earth within about 35,000 miles or so, and this asteroid's 30 or 40 feet across, big enough to cause not much damage, but still kind of startling that something that big can come by and we only have a day's notice. And yesterday, an asteroid that was bigger, like the size of a school bus, passed within 200,000 miles. It's unusual for two asteroids to come by 2 days in a row like that. The school bus-sized one could have gotten through the atmosphere and caused some damage on the ground.
But none of them are big enough to really destroy a city or anything like that.
Yeah, an asteroid, a 50-foot wide asteroid, these things move like 60 or 70,000 miles an hour at least, some faster. A 60-foot wide asteroid packs the wallop of an atomic bomb, but it's not likely to get through the atmosphere. But a 100-foot wide now you're starting to talk about something that get through the atmosphere, like the one last year that hit Russia back in February 2013. That one exploded in the atmosphere. Some fragments got to the ground, but mostly it was a shock wave because it exploded right over a major city in Russia and injured like 1,500 people, mostly from flying glass. And if that had happened in New York or London or Tokyo or Beijing, it could have been much worse casualty rate.
Yeah. So with the 100-foot model, comes into the atmosphere, what happens? Part of it is like sheared off.
Right. It might.
So then you get a 50-foot model at the end of the day.
Right.
And that's the part
that hits the ground.
That's bad.
If the 50-foot one had hit the ground, going 60,000 miles an hour, it would have been like an atomic bomb.
Yeah.
It would have been that devastating.
Yeah. And shock waves and fragments and spewing in every direction.
Yeah. The ones that they think are really dangerous, the extinction possible ones are the ones that are over 1,000 meters across. If they're bigger than a kilometer, 0.6 of a mile, there's a chance they could cause devastation over at least a continent. And they think the one that extincted the dinosaurs 65 million years ago was about 6 miles wide, 10 kilometers.
Is that what happened to the dinosaurs?
That's one of the leading hypotheses from the dinosaurs. There's this huge crater at the Yucatan Peninsula. Yucatan sort of looks like the edge of a crater, and they can drill down and see the fractured rock that's clearly an impact fracture, and calculate how big the thing was. And the interesting thing about these, we know how many of these big ones there are at least. We think we've got 95% of the 1,000-meter ones, the extinction level ones, tracked. The ones that are smaller than 50 feet, we know we don't have them all tracked. There's thousands of them out there, but we don't care because they're not going to get through the atmosphere. Ones in between, there seem to be a few more of them than we thought. So we can have local devastation from those ones that are between 50 feet and 1,000, or between 50 feet and a kilometer, which is 1,000 meters about 6,000. 1,000 meters about 3,000 feet wide. So between 50 feet and 3,000 feet, there's a lot that we haven't been able to track that could be dangerous potentially.
Where do they come from?
Well, the asteroid belt. The thing about, so there's thousands of objects out there orbiting the sun. Most of them are orbiting between Jupiter and Mars in the asteroid belt. Every once in a while, Jupiter will kick one, and it'll change its orbit, come closer to Earth. Now there's at least hundreds of Earth-crossing ones, orbits of asteroids whose the difference between where they're farthest from the sun and closest to the sun brings them within the Earth's orbit. Most of them will never hit the Earth. But the problem is that when you've got more than two bodies, more than just a star and a planet, but more, you have a chaotic problem. It's famously chaotic. Three-body problem is impossible to solve. a very small change can lead, a very small change in how fast something's moving in its trajectory can lead to a big change later on in where it ends up. And it's exquisite sensitivity to initial conditions, and it's also sometimes called the butterfly effect. You know, a butterfly in Africa causes a tornado in Kansas. Whether it's there or not, the tornado happens or not. So a small kick to an object can, over time, cause an unpredictable, possibly catastrophic situation. There's an asteroid called Apophis that they've found, I think, in 2009. It is predicted to come within 23,000 miles of the Earth in 2029.
Is that close?
That's really close. It's going to come closer than our geosynchronous satellites. Now, the Earth's only 8,000 miles wide, so there's still room. But because of this exquisite sensitivity to initial conditions, they don't know what it's going to do after that. They know that it's likely after that to come loop back around for another pass in 2036. So from 2029 to 2036, the Earth's orbit will have perturbed that asteroid's trajectory to the point where we don't know right now whether it's going to hit the Earth or miss again.
Or could it be that just spin around the Earth in the gravitational force?
That does happen. Sometimes Earth captures small asteroids. They kind of loop around and do chaotic things, and they get kicked out again by the way the Earth and Moon perturb them. It could happen. I don't know what the odds of that are. It's very unlikely it's something that big would get captured like that. Yeah, it'd be like a hole in one. Yeah. Yeah, so we have two moons then. And,
that would be something.
Yeah, every once in a while, though, the Earth captures one of these smaller asteroids, and it loops around the Earth for a while between the Earth and the Moon, and it's a chaotic situation. Eventually, it's kicked out again.
Yeah.
So
20,000 miles is close.
Yeah, it's close. In astronomical terms, it's as close as you want. On the other hand, from the point of view of human beings and life on Earth, a miss is as good as a mile. I mean, if it misses us, we don't care whether it's 20,000 miles or 200 million miles, it's missed us.
So, is this a needle in a haystack kind of thing, or is, like Iniki?
Yeah.
I mean, after a while, one's going to hit us splat.
Yeah. Well, right now that's the way it is. I mean, even if we saw something that was a kilometer wide coming at us, we couldn't do anything about it right now. If we knew, like with Apophis, if in 2029 when it comes by, we calculate its new trajectory and say, oh my God, it's going to hit us directly in 2036. Well, in those 7 years, if we were to get there quickly, a tiny nudge could push it just enough. But the longer you wait, the harder the nudge has to be. And nudging something that weighs thousands of tons takes energy.
And it's going that fast.
Right, when it's going that fast. So if you were to nudge the asteroid Apophis in 2029 by just change its trajectory by a millionth of a degree, that would be enough to cause it to miss the Earth 7 years later, if it was on a collision trajectory. So we don't yet have the technology to do that.
A great strategic war game.
Yeah, it does, doesn't it?
I can go up there and do that nudge and have it hit my adversary's capital city.
That's a very interesting observation. Yeah, because there's people talking about mining the asteroids, and the technology we need to go mine an asteroid would be also the technology needed to save the Earth of an asteroid collision. But if you can mine the asteroid and bring enough minerals back to Earth to be economically suitable, unless it's like platinum or gold or something really valuable, but if you were to bring 50 tons of nickel or molybdenum to Earth, you drop that 50 tons on somebody's city, and
so you get the metal, and you destroy the other guy's city.
Right.
But it's a double whammy.
There it is.
Whammy in the true sense. So what are they normally made out of? I always thought they were made out of cheese.
Yeah, those would be some big cows in space. But no, there are various combinations. There's a lot of metal asteroids made of iron and nickel, and those get through the atmosphere pretty easily. Then there's a lot of asteroids, carbonaceous chondrites, things that are made of carbon compounds like rock, silicates, things that. And I'm not an expert on the asteroid composition, but there's a whole bunch of different so most of them are like loose rubble piles that have come together under weak gravity and gotten together. Some of them are collision products where something big got hit by something else big, and I have all these big heavy fragments like the iron meteorites.
So what's the explosion process when they explode, either by hitting an atmosphere or I guess they could explode for a number of reasons.
Well, they could hit each other. I mean, so there was a huge amount of asteroid formation and asteroid collisions back early in Earth's history, 4 billion years ago, or 4.5 billion years old or so. And that's eased down as these things, eventually accreted into planets or bigger objects, or burned up in atmospheres, got kicked out of the solar system, those kinds of things. So there's a lot of them out there still, though, and our name is on one of them. We just don't know when. So, but this whole idea of deflecting them is, you think about it, and right now with our current technology, we could, if we could see it early enough, rendezvous with it, which is hard because these things are spinning mostly. So trying to land on a spinning object.
Sort of lopsided spin.
Yeah, it's a lopsided spin.
They're not exactly round.
They're not exactly round, most of them either. So you're trying to land on this spinning sweet potato thing, and if you can calculate its spin axis, maybe you can land on the pole, and then proceed from there to go down to where you need to go to nudge it.
You mean a person? Could a person, exist in that kind of gravitational force?
It's not much gravity, but it's a centrifugal force. The spinning.
You get thrown off.
Yeah, you get thrown off. If you could get thrown off, that would mean it would have most likely broken up. So really, the things that are spinning really fast, where you get thrown off, probably also are disintegrating.
Yeah. Do they? I mean, like, I'm thinking of a pitcher and a hard.
Right. Oh yeah, you could probably jump off. Yeah.
So there's not much gravitational force because the gravity of the mass is opposed by the spin, which is spinning things away.
Yeah. Yeah, you could easily on these asteroids.
Great movie. This is a movie.
I think that's a great idea. I think I'll pitch that to Hollywood. See what we would call it, Armageddon.
So in your model for deflecting them or stopping them somehow, I mean, do you think that there's any reality to having a person do this job?
No, that would be
look like Tom Cruise, for example.
I'm thinking more like that Die Hard guy. What was his name?
What's the name of the Die Hard guy? Bruce Willis.
Bruce Willis, it's more like Bruce Willis,
and he gets bloodied up in the process.
Yeah, that's right. No, it would be foolish. We don't need to send people to the asteroids to do this. We could send robots to do it, but they have to be highly autonomous because you don't know what you're going to get when you get there. You have to be able to assess how it's spinning, where you can land. There have to be a lot of autonomy because the radio time from here to the asteroid belt is hours. I mean, you would never control a craft in real time.
Yeah, you couldn't because of the delay.
Because of the delay.
You have to observe and get command.
I say hours, I meant minutes. So it's minutes to go.
Minutes.
But still, minutes is a long time.
So fast.
Yeah.
So how would you do it then? Would you send, this is out of Dr. Strangelove, would you send a bomb up there to blow the sucker up?
Well,
there's a lot of guys who'd like to do that. They'd have
they would like
a real
to do
thrill blowing up a bomb in space.
But there's no guarantee that you'll actually blow it up. You might just set it spinning in a different direction, and you don't know what it's made of. Until you know what it's made of, you don't really know whether the bomb's going to work or not.
Could it be radioactive?
Most things are a little radioactive, but the easiest thing to do would be to rendezvous with it. Try to see it early. Like there's starting several countries that want to start up projects, and it would probably take international effort of telescopes to try to see these things early. And even here in Hawaii, I believe the Institute for Astronomy has some researchers are starting to look at how to get an early warning of the things that are dangerous, big enough to be dangerous, that we haven't yet cataloged. And if you can get enough warning, you don't need to bomb it. You just need to send a small rocket there to push on it, or you could even unfold a Mylar sail, let the sun push on it. You could even do what they call a gravitational tug, put some heavy spacecraft there, and let the gravity between the asteroid and the spacecraft deflect the asteroid without even touching it. And if it's spinning really fast, that might be your best option, is to try to do a gravitational tug. But that takes a lot. You have a lot of warning if it's a big one in order to deflect it enough.
You got to build the spacecraft.
You got to build the spacecraft.
There's not an airfield full of these spacecrafts ready to go for an asteroid.
Yeah, I mean, the United States has sent some missions up to rendezvous with asteroids and comets. The Japanese have, the European Space Agency has, but these aren't spacecraft that are designed to actually do anything about it. They're just designed to go take pictures or maybe shoot a probe in to see the plume of stuff that comes up when the probe hits the surface and try to measure what's on the asteroid.
So, but theoretically, though, if you had a couple of hits, and we started getting, if this got higher in our priority list, and we're willing to spend some money on it, and I think you should probably answer this after we have the break. But
another break. Okay.
Yeah, but what would this spacecraft look like? How big would it be?
That's a good question.
How would it be specially outfitted?
Yeah.
What kind of special tools would it have, and what would be its its operation? Its options out there in space to stop this in the minimum of effort.
Right.
And wow, exciting! The movie is unfolding, Mike.
The movie is unfolding. Absolutely. So this is. This is ThinkTech. The show is for the benefit of humankind. I'm Mike Deweert, talking to Jay Fidell about asteroids, and we'll be back shortly.
I'm Jay Fidell. That's Sharon Moriwaki of the Hawaii Energy Policy Forum. And every Wednesday we have Hawaii, the state of clean energy. We've been doing it for some time now, and we have some fantastic guests on there, unbelievable guests who give us insight into what is going on in a very complex, sometimes very confusing, sometimes very disappointing area of progress in the state. So we love doing this. We love meeting them. We love talking to them. We love having their ideas out on the table. So maybe, just maybe, we can all make some sense of what's going on. Sharon, what do you think?
I think that's absolutely correct. We enjoy ourselves meeting with all these people and hearing about the energy and the state of clean energy, and hopefully we advance clean energy for the state. So it's terrific. Join us.
Okay, it's every Wednesday. Okay, Wednesday is Energy Day. Every Wednesday, 4 to 5 p.m. Hawaii, the state of clean energy, here on ThinkTech Hawaii. We'll see you there.
Aloha, this is ThinkTech. I'm Mike Deweert. The name of this segment is For the Benefit of Humankind. And today Jay Fidell and I are having a nice science fiction discussion about how to deal with the asteroids that inevitably will hit the Earth. We don't know when, we don't know how big, but we know it'll happen. So, and here we are talking about asteroids.
I wonder if they're caused by climate change. No, can't.
They could cause climate change, though. It's interesting. So, if an asteroid big enough hits the Earth, what will happen is it could send a shockwave through the planet that focuses on the other side and causes a magma plume that will cause a supervolcano potentially that would cause climate change just from the volcano itself, let alone from what the dust the asteroid itself is kicking up. One could imagine, and the size of those things isn't clear, because if it were to hit in a place that would, say, set off Yellowstone supervolcano or the Deccan Traps supervolcano, it would take much less of an impact to set that off. And if the Yellow supervolcano goes, forget about North America. There won't be a United States or Canada anymore.
Just be a big volcano spewing out what volcanoes.
It'll be unlivable, and then the volcanic dust
is just as well over the place.
Well, there'll be a lot of magma, but there'll also be a lot of dust. So a volcanic winter. And of course, there'll be hot ash falling everywhere and smothering things. Agriculture will be impossible for a while, wherever that plume lands. So oddly, an asteroid, big enough asteroid hitting the Earth could cause a volcanic winter, but from the other side. So you're not safe on the other side of the planet.
China.
So, yeah, well,
if it hits North America, China's the one who gets the volcanic winter.
Actually, it hits North America. Well, the antipodal point is in the Indian Ocean. So anywhere in North America, you'll end up in the Indian Ocean. So if it hits the Indian Ocean, it could end up causing Yellowstone to go off.
All these years, I've been taught that if you start digging a hole right there in the ground behind your house,
right,
just next to the doghouse there behind in your backyard, if you dig that hole, you will wind up in China. That's what I've been taught.
And that's why Canton, Ohio was named Canton, Ohio, because the people that founded Canton, Ohio thought it was opposite side of the planet from Canton, China, which is, of course, exactly wrong, because both Canton, Ohio and Canton, China are in the northern hemisphere. They can't be on the other side of the planet from each other. So
there you go. He's our chief scientist, but the fact is that he's in the wrong place. He needs to be in Hollywood.
Oh, thank you. I'll have Tom Cruise play me in the movie about my life.
I can play Bruce. Bruce Willis
can play you. We're in an exploding ThinkTech studio and some nefarious super criminal to thwart.
So here we are. Now the first one is where Bruce Willis goes up in a spacecraft and he's charged with trying to stop this asteroid, which is pointing directly at the Bronx.
Right.
And which would be a bad thing. And then now we have the sequel.
Yes.
And the sequel is where we have a battle of asteroids, as if they were personified, coming from some far galaxy, whatever. And there's lots of them. And we can't stop them all, and they're all going to hit, and they're going to destroy the Earth, just throw everything off kilter. And that's the next movie. Right. So how do
That's
we
where you
handle...
need President Morgan Freeman to start a crash program to save the species from extinction.
Literally a crash program, literally. Perfectly crashed. But I mean, how do we deal with the receiving end of all of this? I mean, I know we had a show yesterday with a Coast Guard guy who talked about continuity of service in the event of disaster everywhere, but especially here in Hawaii. How do we deal with this kind of disaster? It sounds like there's nothing you can do. You're talking about early warning systems.
Your early warning system, if you got enough warning, you might send up a spacecraft and do something about it. And it wouldn't be the Bruce Willis thing where you're drilling a hole in the asteroid and trying to put a nuclear bomb in it. It's most like if you have enough warning, you would either use a gravitational tug, which is just a massive ship with enough propulsion on it to sort of gently lead the asteroid up to one side or the other of its orbit just by the gravitational pull. Or if the asteroid isn't spinning too fast, you might conceive of putting some kind of mylar big solar sail on it to use the sunlight to push it away. And over years and years and years, that could nudge it enough.
Got to get out there, though.
You got to get out there.
You travels at 50 or 60,000 miles an hour. That's
and you need to be millions of miles away for this to actually, for you to have time. You need to calculate a couple orbits before it actually hits. Yeah. So.
You have to have a whole community of Bruce Willis's, so great-grandchildren can do their thing.
Yeah. Well, we'll use robotic spacecraft.
Robotics can last more than one generation.
Yeah. So.
Okay. So what about? I'm interested that IFA is looking at this.
Oh yeah.
But query what kind of technology is available to see hurtling objects of, say, what did you say, 50 feet in diameter?
Oh yeah.
At millions of miles away. That's pretty sophisticated.
Like the 35-foot one that's coming by today, we didn't know till yesterday it was coming. The bus-sized one, we probably knew a couple of weeks ago. A kilometer one, we can know, years in advance. Those are big enough, unless they happen to be really dark. We know we haven't seen all of them. We're pretty sure we've only gotten about 90 or 95% of those extinction level ones. The scariest thing would be if it's coming up behind us in our orbit, so that we can't. So it's coming up where our telescopes are. We'd have to look towards the sun to see it. That would be the hardest thing to see.
You can't see anything very well.
Yeah, because if you're dazzled by the sunlight, how do you got to reject the sunlight in order to see this little tiny point? That's very hard to do.
And the sun has all these speckles on it anyway, because it isn't constant light.
Yeah. So you need a wide field telescope. You need to be able to look at a large amount of sky, but you need to be able to do it with a very high resolution, which means you need a big lens, a lot of pixels on your receiver. You need to look for a long time, because what you're going to look for is some point of light that's not moving like the others against the background of stars.
And then compare its trajectory with the other moves in the sky. I mean, I hate to do digression on you, but this reminds me of all the action over the 30-meter telescope on Mauna Kea. I mean, all of a sudden, after 12 telescopes up there, the 13th one, maybe it's a numerology thing, becomes a problem and a cultural, issue. And then we find that another consortium wanted to build a 100-meter telescope, but they shaved that down to 39 meters.
Well, it's
And
an
our building
order of magnitude easier to build.
Yes, exactly.
Yeah,
I mean,
yeah.
maybe I got this backward. It could be that they shaved it down from something else, but it's 39 meters, and it's going into Chile.
Chile, yeah.
Okay, but then they got another one planned, which is 100 meter. I think that's the way it is. And I mean, it's scary that what's happening is sort of like in the airlines, is we are getting flown over. Had we been able to build a 30-meter telescope, I suggest that we could have built the 39 here and maybe the 100.
Sure.
But the world, world memberships of these consortiums that can raise billions of dollars for telescopes aren't going to come here.
Right.
I think we've already shut ourselves out of anything beyond the one.
The 30-meter
that will be
telescope we
built there
have
now. I think we're done, actually.
Yeah, it'd be a shame for Hawaii astronomy. On the other hand, you've got to, at some point, respect the wishes of the majority of the people. But you would also like to think, oh yes, if they can convince the majority of their legislators to do something, then you might as well have the majority. But you would think the scientists should be better able to communicate, because Polynesians made their living navigating by the stars for thousands of years, and they're of as much interest in understanding the stars as the rest of the planet does.
Well, it's important,
And,
not only for navigation, but it's important for asteroids.
Right,
We're talking about these early warning systems.
Yeah.
Undoubtedly, they are done through these big telescopes.
I think perhaps a failure of education. I mean, you go to Imiloa and they start to try to integrate the culture with the science. The Imiloa Science Center on Big Island, if you get a chance to visit, go. It's an amazing
right
place.
Above the university.
Right above the university,
Top of the hill,
top
beautiful
of the hill.
building.
Beautiful building, very nice cultural exhibits, trying very hard to show how our understanding of the universe has changed over the last few thousand years, and try to integrate some of the traditional approaches towards understanding the universe with the modern scientific approach. And even the West, doesn't really adhere to the scientific approach all the time either. I mean, we still have people in the West who insist the Earth is only 6,000 years old. So we can't blame one culture or another. There's just a failure of communication and a failure to understand or communicate the science, I think.
In the process, we lose something, though, because Hawaii is a relatively sophisticated place about astronomy. We have IFA. Okay. We have 12 telescopes up there. We have an industry of people who are acquainted with all the science around telescopy. Did I get that right?
Around
telescopy.
Oh, telescopy. Okay.
Telescopy.
Yes. With that, we should take a break. This is ThinkTech. The segment's called For the Benefit of Humankind. My name is Mike Deweert, and we'll be back in a minute to talk more about asteroids or whatever tangent Jay leads me off on.
Aloha, I'm Jay Fidell. This is ThinkTech Hawaii, broadcasting live from the Pioneer Plaza in downtown Honolulu. We raise public awareness about tech, energy, and globalism in Hawaii. Technology is critical to our state. A vibrant tech sector will give us new prospects in the global marketplace and will offer great careers and make our economy more resilient. Streaming live on Ustream and Spreaker, ThinkTech allows its hosts and guests invaluable opportunities to report important events and discuss important questions, and to be heard here in Hawaii and around the world. You can find links to our live streams on thinktechhawaii.com or on our mobile website, m.thinktechhawaii.com. And you can see our archive on YouTube. It's all just a click away. We want to do whatever we can to keep Hawaii relevant, connected, and thriving in the complexity of the 21st century. We hope you will help us in those efforts. Tune in today. This is ThinkTech. I'm Jay Fidell.
Aloha, welcome back. My name is Mike Deweert. This is ThinkTech for the Benefit of Humankind. And we are talking about asteroids and how we might survive or prevent or somehow avoid the almost inevitable consequence of the inevitable asteroid coming at us. And I'm talking to Jay about this. So, I don't know, Jay, if we ever were to actually see this thing coming, what would we do if we determined that we couldn't deflect it? I don't know how we would. It would be very disruptive for a civilization.
There's a parallel with sharks.
Yeah.
Sharks actually eat people. Mm-hmm. They're fairly nasty about it.
Yeah.
And they eat tourists, which are our mainstay.
Yeah.
And yet we don't let anybody do shark teeth. Can't make shark fin soup.
Well, because they're the top predators in the ocean, and they're responsible for the ecosystem, cleaning up the things like jellyfish and stuff that would otherwise overwhelm us. Yeah, it'd be nice. Yeah.
Anyway, so maybe there would be people say asteroids come from the heavens; they must be good. Sort of like a cargo cult thing. If they're coming from the heavens, they must be good. So let's just enjoy. Let me give it to me. Give it to me.
I'm sure there are people who think that we don't mess with nature no matter what. Yeah. If nature wants to make us extinct with a 10-mile wide asteroid, so be it. I'm not that friendly to nature. I would think our purpose is to predict and control nature for the benefit of humankind.
Yes.
And so if we can predict when this asteroid's coming, if we can do it well enough, long enough in advance, we have a shot at doing something to deflect it.
So what we do?
But aside from spending a spacecraft there and putting some kind of, perhaps by then we'll have an ion engine, nuclear-powered ion engine that can really deflect something hefty if necessary.
What about a big laser? I guess it would have to be from the top of some mountain.
Yeah.
I think people would probably object if it was Mauna Kea, but a laser.
Well, the problem is the Earth is spinning and the asteroid's coming in, and you got to keep it on the asteroid, even whether you're at night or That's going to be really hard. Once it's so close that you could do that, it's going to be very hard to do anything about it. You really want to see it years in advance.
Yeah.
And then you really want to get some kind of a spacecraft out there with this, I don't know if you're going to put a solar sail on the asteroid, you're going to put a little ion engine on it, and
it's an ion engine.
An ion engine is, you remember Star Wars, the TIE fighters? TIE stood for Twin Ion Engine. It's a very advanced kind of engine that can accelerate particles close enough to the speed of light to really give you a good impulse with a very little mass. So NASA's experimenting with them, and so far they've used them on a few small spacecraft. So the thing about propulsion is that the faster the propellant goes, the less of it you need. And getting things going close to the speed of light is really important. From that point of view, then you need very little propellant to do a given job. So if you saw the movie Elysium, and you saw this spacecraft that's like the size of a minivan flying up into orbit, and I saw those little engines, and I thought, well, that's bogus. Then I thought, you know what? If they had ion engines that could accelerate matter to a tenth the speed of light, if they had nuclear power with fusion, then an ounce of nuclear fuel and a few hundred pounds of reaction mass accelerated to a tenth of the speed of light could get that 100-ton spacecraft to orbit. So this isn't loony. We don't know how to do it yet, but we do know that the energy should work out with nuclear power, ion engines. We know that there, at least in principle, looks like there's a solution there. And if we could get that technology going, then we would have a shot at even deflecting the asteroids that were not years, but maybe months of warning ahead of us.
Well, so I know this is mundane compared to the giant space things we've been talking about, but what about, suppose we don't have the early warning system, and we have, say, 24 hours, we find out. And we find out it's a big sucker. It's when it gets down, it'll be the remainder of it'll be, say, 50 feet wide, nuclear blast, quality of collision, and it's headed right for Honolulu. It's at the corner of Merchant Street and 4th Street Mall, right out there.
Well, I won't get a plane ticket off the island, and the ship won't get you far enough, fast enough. So,
could you escape? What would you do to move millions of people? Could you get out of the way, or would it be just simply too late?
With 24 hours notice?
Yes.
I don't think you could do it with 2 weeks notice. I mean, you got to move 1 million people out of our little airport here.
I suppose move them to Kailua.
Oh,
we have a new shopping center. We can all, camp out in the shopping center.
It depends how big the shop. Yeah, so again, these things are very chaotic. When it hits the atmosphere, it could deflect a little bit, so you don't know whether it's going to hit Kailua Shopping Center or Ala Moana Center, so where do you take refuge? I guess, that's one reason we really want to know as much in advance as we can, because once that thing's coming, once we have a day or even 2 weeks. It's too
What are you
late.
going to do? It's
Yeah,
not,
they
the
can do it.
planes won't be able to carry but a fraction.
Of course, and it could, even if the
We
asteroid
don't
missed
have a
on-
super ferry.
That's true.
If we had a super ferry, we'd be a little better off.
Yeah, and it really doesn't have to hit Honolulu. It has to hit anywhere in the Pacific Ocean. A kilometer-sized object hitting anywhere in the Pacific Ocean create a tsunami that would devastate us. It would devastate all those other cities on the Pacific Rim, but of course, we have no way to evacuate people. And so once that tsunami wave starts coming from wherever in the Pacific, we'll have maybe a day of warning there before it hits us.
Well,
at
but
most.
something you said really interested me is just a little bit of deflection as it comes down through the atmosphere could change its path.
Right.
And so, are you saying, Mike, that we really wouldn't be able to tell with any degree of precision where the thing is going to ultimately collide?
Yeah, I think that's right. I think we can't really be sure where it's going to collide because the Earth's atmosphere expands and contracts from solar heating over the course of a day and a season. The Earth's spinning 1,000 miles an hour. It depends on whether it hits it day or night. The atmospheric effects, it depends on the season of the year what the atmospheric effects are. Yeah, we could be we could be off by half a mile, or even a mile, or even a few miles. Even if we know a day in advance it's coming.
Sounds like we will be off. We won't be on.
Okay.
We can't. That would be an aberration if we were on.
Yeah. So my view is I agree with the astronomers who are trying to raise the alarms on this one. This is something that only the human species could foresee and prevent. And we're not the cause of it, but we're the only way the planet has to defend itself from it. And we should try to figure out how to do this as long in advance as we can. So anyway, well.
Okay.
So we got to wrap
That's
up.
enough. That's enough food for thought for sure.
Well, we've had 2 small asteroids come close to our planet on successive days this week, and we've been talking about the big one, how we would see it, how we would stop it, what we would do if we couldn't stop it, and well, perhaps the solution is to live every day like it's going to be your last, and make sure you keep your affairs in order. So, or just have the foresight to do something about it in the future. So my name is Mike Deweert. This is ThinkTech. The name of the show is For the Benefit of Humankind. I've been talking to Jay Fidell about asteroids and global climate change, and next week we'll be on with a guest. And until then, hui ho, and thank you.